Okay, so taking a look at chapter 7. So you'll notice we are starting off talking about ratio and proportion. I wonder why that's important in geometry. Don't worry, I'll tell you all about it. So first, we're basically going to refresh our memory on some of our ratio and proportion. What are they? What are the rules? How does this work? So let me grab a pencil here. All right, so if we just take a look, we have two definitions, sort of. So a ratio is a comparison of two numbers in the same unit. That's important. So if I'm comparing like feet and inches, I want to convert feet into inches so that I can compare them. So we want to be in the same unit. So a ratio compares two numbers in the same unit through division, while a proportion is an equation that compares two equal ratios. Okay, so that's really the difference. You have two ratios that are equal to each other, and that would form a proportion for you. Okay, so let's review some of the properties of proportions. So if you have two fractions which really are equal to each other, then all of these following things are true. So let's explore these for a moment. I'm sure you remember that if you multiply the diagonals, the cross products, it's called the means extremes property, if you didn't know, but that gets you A times D equal to B times C. What I'd like to do is try this with some numbers. How about, I have here, let's pretend that our original proportion was 2/4 equal to 6/12. First of all, that's true, right? Isn't 2/4 really the same thing as 6/12? Yeah, so I do have a true proportion. So now the claim is if I do any one of these four things, it should stay equal. So let's try it. If I do multiply the diagonals, so that would be 2 times 12, I'll just write it up here. 2 times 12 in my example is supposedly equal to 4 times 6. Is that in fact true? Yeah, it is, right? 24 really does equal 24. So yes, that is absolutely true. Take a look at the next one. Look at what has happened. We have basically taken one diagonal, the B and C, and swapped them. Do you see that? So hold on a minute. You mean to tell me if I have a proportion and I take one diagonal and swap it, it's still going to be equal? Let's try with our numbers. So I'm going to take my original proportion. I'm going to swap just these diagonals. So the claim is that 2/6 would now be equal to 4/12. Is that true? It is. It is. You absolutely can swap a diagonal. Isn't that interesting? In fact, if you wanted to, it doesn't matter which diagonal you switch, by the way, you could switch the other one. You could switch both diagonals if you wanted. I know that's not in this list, but let me just try. If I swap both my diagonals, so that would put me at 12. And I put the 2 down there if I swap those two. And now let's swap these two. I'd have the 6 here and the 4 here. Get out of town. Isn't that wild? Isn't that wild? Because 12/6 really is the same thing as 4/2. My goodness. The magic of proportions. I got to tell you, we were just talking about this in Algebra 3, because some equations are so much easier to solve if you swap a diagonal, for example. And some of them were not doing it the easy way. They were doing it the long, annoying way. And I'm like, guys, just swap the diagonals. And they did not know what I was talking about. Like, oh yeah, swap them. So much easier. Any users, let's take a look at the third one. The third one, do you see what has happened in the third if you compare it to the original? What did they do to get this third one? They took the top and bottom. Exactly. If you take the reciprocal of both sides, it remains equal. Both sides, just flip both of them over. So that would be 4/2 and 12 over 6.
Pretty much just swapping both diagonals. It's just that the fractions are in a different order.
Exactly. Oh, there we go. Yeah, so you can take the reciprocal of both sides. You can swap one diagonal. You can swap both diagonals. Oh my goodness. Now the fourth one is very interesting. And I wonder if, let's try it with numbers and see if we can follow it, and see if we even believe it. And then let's see if we can figure out how they're doing what they're doing. I think this is actually a homework problem later. So if you, I'm pretty sure. All right, let's try it. So in my example, this is A, B, C, and D, right? So let's see, they're saying A plus B, so that would be 2 plus 4 over B, which is 4, should be the same thing as, let's scoot over smidge, C plus D, so that would be 6 plus 12 over 12. So let's simplify and check. I'd get 6 over 4. Is that the same thing as 18 over 12? Oh, it is. Okay. But what did they do from the original proportion to come up with this thing? Can you randomly just add things like this?
But it's not right.
It's not random. They've done something to both sides that will kind of make sense. Eve, what do you think?
Like you're adding the denominator, but then dividing by that same number.
You're right. And what is it when you have the exact, when you have a fraction and you have the exact same thing in the numerator and the denominator, what's it really?
1.
Yes, that's basically what they've done, is they've added 1 to both sides. So let me break this down a little bit. I could rewrite that fraction as this: A over B plus B over B. Isn't that the same thing? Right? Couldn't I just split that fraction up? My A looks like a 9, sorry. A. Right? That's that same fraction. And let me do the same thing over here. If I took this one and I split it up, I could do it as C over D plus D over D. And because that and that's really just 1, right? All they're really doing is adding 1 to both sides. But if you add it in a smart way, right? If I add whatever my denominator here, so instead of just adding 1, I can add B over B. Instead of adding D, I can add D over D. And then it turns into this. So these are just 1. You're adding 1 to both sides. Oops. Adding 1 to both sides. Okay, so are we feeling okay with proportion so far? All right, now you'll see all the way over on the right, sort of squeezed in here, is this extended proportion. So I'm sorry that there's not a ton of room here, but let me show you what's going on with this. All right, so here's what an extended proportion. Here we're talking about 3 or more equal ratios. So for example, if A over B is equal to C over D, which is equal to E over F, and you can keep going if you want. So here's a claim. If the above ratios are equal, it's also true that, you ready for this? Zoom out a bit so we can get it all. A plus C plus E plus however far you're gonna go, all divided by B plus D plus F plus however far you're gonna go, is always going to shake out to just be equal to, you ready for this? A over B. Oh, you know what? I think this is the homework problem, this one. Should we do it together now? So you don't have to do it later? I figured as much. Okay, so I think they ask you to show. I need a different sheet of paper. There's no way I'm gonna put it on there. So let's try this. I think this is number 41. That's what I have written down as anyway. So I assume that that's correct. So the claim is if A over B equals C over D equals E over F, then show A plus C plus E over B plus D plus F actually equals A over B. My A's keep looking like 9. I apologize. They are not 9s. All right, anybody have a thought? Somewhere where you want to go with this? Mull it over. See if it, you want to, let's try it once with numbers. Now, doing it with numbers doesn't prove that it's, because you would only prove that it's true for that one case. But let's just see if it is true with numbers before we start doing anything else, okay? So that wouldn't prove the whole thing, but maybe that'll help wrap our minds around it. So we need 3 equal fractions here. I just always stick with a half. So let's say we had a half, maybe 3/6, and how about 4/8? All of those are equal, correct? Right? They're all equal to a half. All right, cool. So now the claim is if I add all the numerators together and I add all the denominators together, and then I reduce that ratio, I should get 1/2. Weird. Okay, let's try it. So if I add 1 plus 3 plus 4, does that really equal 2 plus 6 or not? Add those. Does that equal 1/2? Well, let's see. 1 plus 3 plus 4 is 8. And then downstairs, 8 plus 8 is 16. Well, what do you know? So, I mean, it is true in this one instance. We want to prove that it's true all the time. So if I have 3 equal ratios or more, right? Keep going. If I have the string of equal ratios and I added all the numerators and added all the denominators and reduce that fraction, I would always get right back to the first, or any one of the individual fractions, right? Because they're all equal to each other. Huh. Allow me to give you a little hint. What if we introduced an outside variable to sort of help us along the way? Let's say, for example, let's say R was equal to A over B. Now, I have created for myself basically a new proportion. I can now say that A is equal to B times R, right? Couldn't I just multiply both sides by B? So A is now equal to B times R. Now watch this. So I have replaced this with R, right? So now I could say that R is equal to C over D. So therefore, R is equal to C over D. So couldn't I do the same thing and get C equal to D times R? Do the same thing with your last fraction. So what would E end up being equal to? E is equal to I heard R times F. I'm gonna write it as FR if you don't mind. Oh, I'm sorry. Have I lost anybody so far? We're okay? We're all following this? So I just picked a random variable R to represent my first fraction. That first fraction, right? If I just solve it for A, I'd have A equals B times R. Then I do the same thing for each of my others. R, if I'm saying A over B is equal to R, that means all of them are equal to R. So R is equal to C over D and R is equal to E over F. Now, the reason why I'm doing this is because I'm getting rid of A, C, and E, and I'm writing them in terms of B, D, and F times R. But now watch how this helps me. Since I now have these to work with, I'm trying to show that this is true, right? So let's go to what I'm trying to prove and replace that A, B, and C, or I'm sorry, that A, C, and E in that numerator with what they're equal to. Okay, all right, so what's this? So to show A plus C plus E over B plus D plus F equals A over B, replace A, C, and E with what we just found. Check this out. So A is no longer A, it's B times R. BR plus, instead of C, I write DR. Instead of E, I write FR. See what I did? Now, simplify that. Look what happens. What can I do with this thing? What can you do with that numerator? Yeah, I'm going to do it the other way. I'm going to pull out the R. Don't they all have an R in common? Let's factor out that R, and then I'm left with that B plus D plus F. On the denominator, I have B plus D plus F. What does that mean? What can I do? I can cancel them because I have all of that and all of that. So I'm left with just R, and R is just equal to A over B. Oh my gosh. Isn't that something? So if you have, the takeaway is, if you have a whole bunch of ratios that are equal, you can absolutely just add all the numerators, add all the denominators, and their ratio will be equal to any one of the original ratios. Oh my gosh. How interesting. You'll see tomorrow how we use this to our advantage to make our lives so much easier. But I'll hold on to that tomorrow. All right, does anybody have any questions? So today you're really just practicing with the ratios and proportions, making sure you know what you're talking about because we use them quite a bit throughout the rest of the chapter. So let me give you your assignment for today. Where did I put it? Oh, there it is. Let's do. All right, we are going to do page 243. Make sure you're in the written exercises. And I wanted to do numbers 1 through 35 odds there. And then on page 247 to 248. Oh, you know what? I'm not going to assign you the one that we did, but you will need it anyway, so it's fine. 1 through 39 odd. Yes, okay, that's perfect. So feel free to, if you want to work together, that's fine. If you want to work individually, that's fine. I am going to hand out the multiple choice to the people that need to take it. And then maybe when they're all done, depending on how much time we have left, maybe we can go over the multiple choice at the end of class today. All right, so let's see. Did I already put them aside? No, I did not. Okay. Here. Does everybody have the homework written down? Can you write it down? Because I have to move this away from the screen. So I'll put it on Jupyter in a minute. But everybody's got it? Okay. So those of you that are about to take this multiple choice, I'm going to leave this up here. Some of the like the print quality is not the best on this one. So I mean, you can see almost everything, but here, that's just choice A, B, C, and D. So for these bottom 3 questions, it'll explain it here in the directions, but you are choosing, so for number 5, you're choosing which of these is greater. You choose choice A if A is greater, B if B is greater, C if they're equal, and D if you can't tell. Okay, so that's for questions 5, 6, and 7. All use these same 4 choices. Okay, so I will leave that up there. I'm sorry that there are numbers here. It's just super hard to see them. Okay, so Who needs to take the multiple choice from Wednesday? Layla. Anybody else multiple choice from Wednesday? No? Okay. You guys can work together if you want. I'm so quiet. Again, make sure on page 243, you're in the written exercises, not in the, what is it, classroom or something? Sure. My multiple choice people, please don't forget to put your name on the top. There's no name line, I apologize. Oh, you finished? Good, thank you. Thanks. Yeah, send me your phone, please. Thank you. Thank you. Bless you. Liam, you were here on Wednesday, right? You took the multiple choice?
Yeah.
You're my no-name person. But I got you now. How's everybody doing so far? Everybody stuck? No, easy enough? Smarter, not harder. What's that? Oh, Jeff, you want to take the other one back? All right, get that out of the way. You know what? Oh, I forgot, sorry. It's like 3 seconds, but.